This week we started having a look at the maybe monad. We also had a quick look at the either monad. Both of these can be used to handle errors in different ways. Both of them have their uses, but today we're going to be having a look at the maybe monad. Now remember that the maybe monad is either a value of nothing or just and then some value of the type that we're applying it to. So for example, when we did the 1 divided by x function, that would be nothing when you divide by 0. Otherwise it would just be 1 over x, whatever that value happens to be. So it's a way for us to handle partial functions that aren't defined on certain inputs, or errors. You can think of it that way. Today what I'd like to have a look at is the bind operation. Now that's this thing here. It's part of the monad class definition, and what it says is for some monad m, it takes a value ma, a function from a to mb, and returns mb. So what this is saying is it's a function which will take a monadic value and take a function that doesn't actually work on monadic values, but it will raise it to that level and then carry out the calculation for you. This is monadic composition. So you don't really want to think of this bind as, I'm saying monadic composition, but you really just want to think of this bind operation as being like, and then do this. So you give it a value, a function from a to a maybe value, and then another function from a to a maybe value, and then you can chain these functions together. So it's basically just composition. Nothing more than that. It's a way to build up computation without worrying about dealing with monad values yourself. It's similar to Kleisli composition, but that's not something you necessarily need to know about. So the example we have for this today is return the most significant digit of a number as a string. Results should be of the form the most significant digit is, for example, 5 if it was. This should return nothing when we're given a negative number. It should probably also return nothing when we get 0, but I'll show you why I've put 0 in the array earlier. But anyway, I'm going to define 3 functions to help us do this. They're all going to be of the some sort of type a to maybe something, because any of them could fail, because the previous one could be a maybe value, so you don't know necessarily what it's going to get. But let's have a look at this and see what we want to do. Well, the first thing I want to do is get the most significant number value or digit from a number. The way that I'm going to say we do this is we check to see if a value is less than 9 and greater than 0. If it's in that sort of range, 0 to 9, then we have a digit that is most significant. If we don't, then we divide by 10 and we check again. So for example, if we had the number 10, it wouldn't be between 0 and 9, so we divide it by 10, then we'd recurse with a value of 1, and that would be between 0 and 9, and that would then be the most significant number. So that's quite a wordy explanation. It'll maybe be a bit clearer when I write the code. Hopefully it will anyway. So let's say get significant, forget type, signum. It's going to be of type int to maybe int. And what I'm going to say is that get signum takes an x. I'm going to start off by saying that if x is less than or equal to 0, that should equal nothing. Now, it doesn't really make sense for me to say that 0 is a most significant value. So if you have the number 0, it doesn't really have a most significant value because it's not large enough. It doesn't contain a value. It's the absence of a value in a way. It's more of an explanation than we need, or it's more philosophical than we need, so let's just move on. And then what I'm going to say is x is less than or equal to 9, in which case we should return just x. So that's saying that I have a value that's been reduced to just a single integer between 0 or between 1 and 9, and therefore it's the most significant value. Otherwise equals get signum of x div 10. So hopefully that's a bit clearer. We just we check to see if it's less than 10 and that it's not negative, divide by 10, check again until we get a value that's between 0 and 9. So let's save that, and we can reload this. Oh, that's a capital N, not a lowercase n. Let's save that and let's try reloading again. There we go, and let's do get signum, and let's just give it some big old number, not with a t in it though. So we get 1, if we change that to say 8, I get just 8. If we get a 0, we return nothing, and if we have a minus 5 or 56 or whatever it is, we also get nothing. So that's working fine. So this computation could fail, because we've already defined it to say that we don't care about negative values. So now we have a way to get the most significant digit. And then we want to convert it to a string. And that's why I have this array out here, because I want to say, okay, well, if I get the 9th value, take position 9 from this array. That's why I've included 0 here, so that if I get a value 1, I will get the first value, which will be 1. If I get 2, it will be 2. Otherwise, I'd have to get the value at position x plus 1. But again, that will get clearer. So let's say int to string. And we take an int, and we return maybe a string. Now, because this value is defined, or because this function could accept any kind of integer, we still have to check. Even though we know that if we run this function, we'll either get nothing or just a value out, this function takes an integer, so I'm going to define it for all integers. So I'm going to say that x is less than or equal to 0, or x is greater than 9 equals nothing. So if it's not within the range that I can translate to a string, then I just return nothing, because that's a fail for me. Otherwise, equals just, and I'm going to show you this nums, that's the name of our array, at x. So this double exclamation mark, this is like get at position I. So essentially, so if I say nums here at 2, it gets the second position in the array, and of course, because we count from 0, that's the number 2. So that's all this is doing here, that's just saying get at position I. So let's save that, reload this and test it. So int to string, and let's say we give it the value 4. There we go. So we've wrapped it, and of course let's actually test it for other values. If we get 0, nothing, that's fine. And 12, nothing, that's fine. So this is now a safe function, and it is defined for all integers because of this nothing clause. So we have a value that we can hand out rather than just letting it crash. If we left it as a partial function, then we would get a runtime exception, and that could kill our program. However, we're sidestepping this by returning nothing in the cases where we don't have anything worthwhile to return. So next, I don't want to define int to string. I want to define PolishString. So this is going to attach all of this stuff here. And we're going to make this of type string to maybe string. So again, I'm taking the end type here and making it the domain here, so that I can compose these functions later on. So you'll notice this is int to int, this is int to string, so this is string to maybe string. So this will allow us to use a bind operation to actually combine these and run them. So let's say we have a value x's. What do we want to say? Well, we want to say if it's one of these values, then we return just the string, this PolishString here, concatenated with the number that we get out. So if it is part of this array, or if we say x lm of nums, that's equal to, and let's just nick this, and I'm going to say plus plus x's. So if it is one of these values, then just return plus this. Otherwise, equals nothing. And I've forgotten to wrap this in just, so we'll do that. So that's fine. So now we have a function that just says, okay, well, if it is one of the accepted values, then we return s plus x's, otherwise we do nothing. So I've got the 0 value in here, so it is feasible that this function here could attach the 0 value here if we wanted it to. But we know that these two functions will never actually return anything that could give us this 0 function or 0 value out, so that's fine. And I really just kept that there so that I didn't have to write x plus 1 here, or x minus 1, whoever it would have been to manipulate the position of the array. Anyway, let's save that and reload it and hope we don't get any errors. Oh, that's because that should be x's. So we're getting some live troubleshooting. So let's try PolishString, and let's say we give it to, just to make sure, because you're seeing all of the errors today. So the most significant digit is 2, so that's fine. So we can work that. Now, what we want to do is start combining these. Now, they can't necessarily be composed off the bat, because this is maybe an integer, but this takes an integer. So there's a type mismatch there. I can't just compose these functions together, and that's where bind comes in. But you'll notice bind also takes an MA value. So what I can say is, let's say we have just the value 1, 2, 3, 4, whatever that is, some number. Then I want to bind this with get signal. And you'll see that that works because this bind is taking care of the fact that I don't actually have a match up here. So I gave this something of type maybe a, but this function only takes an integer. So actually I give it a maybe int, and it rose this function to the level of the monad so that I could actually apply this. So this is what the bind operation does. It just lets you take values that aren't themselves necessarily monadic, but for a monad that has a definition of bind, it raises them so that you can apply them. Because if you think about it, you might want to define all of these functions that take an integer, they do something with them. You want to use maybe so that when you don't actually have a definition of them, they don't crash, like if you're using head and tails. So you want to define these functions as something to maybe something. And if you're writing a big complex program, you don't want to have to write everything from maybe something to maybe something. You don't have to always write the nothing clause in your pattern matching. So bind takes care of that for you. And for more complex monads, where it's actually quite difficult just to raise something to a monadic value, or it can be a little bit tricky, you don't have to worry about this because bind takes care of this. And of course, if we want to, what we can do is int to string, and then we can combine this with PolishString. And then we get all of those functions have now been raised to the monadic level, composed together for us in Haskell, and it works. So this is the nice thing about using these sorts of monads in Haskell. Let's change that value. So most significant digit is 4. If we put in something that would get us nothing out, we get nothing out. So you can see this bind lets you just ignore all of the nitty-gritty of the monadic composition that you would otherwise have to deal with. If you want, you might think you should try and define all of these as maybes, but you'll have to every single time define a case where you say, oh, I'll get significant number nothing equals nothing, and then you'll have to do that for every one of the functions, and it would get a little bit tedious. So this bind is taking care of all of that for us. It's stitching our functions together for us in a way that makes sense. Now every monad comes with this bind operation, so it's kind of like when we looked at fmap for functors. It's quite similar in that it gives you a tool that you know you can use as long as you're working with a monad. And that's one of the benefits of Haskell's type system, is with these type classes you have this built-in functionality. You can understand how it works. You don't need to know how it works, but you can just apply it and get rid of some of the worries that you might otherwise have. So that's everything for today. I know that we've used a lot of words like monadic and things like that that make this sound a little bit more complicated than it is. Really, you can just read this as and then. So give it a value and then apply get signum and then apply into string and then PolishString. That's all the bind is doing. It's nothing more than that. It's nothing less. So try not to make it seem like a bigger deal than it is. But it's quite cool that we can do this. Anyway, that's everything for today. I hope you found this useful. Of course, if you have any questions, you're more than welcome to get in touch. Thanks.